Hello friends, welcome to Mechanical Engineering online classes. Today's lecture will be delivered by Miss Shravanti Sri Ramoju.
Break-even analysis is a technique which is used to find out a point at which total cost will be equal to total revenue. So this technique we are using to find the best location for our facility. In order to understand it better, we will try to solve a problem. There is a problem which says that potential locations A, B and C have the cost structures as shown below in the table, producing a product expected to sell for rupees 3250 per unit. Find the most economical location for an expected volume of 2750 units per year. So the information is tabulated here. For site A, the fixed cost per year in rupees is given as 65 lakhs and the variable cost per unit is given as 1200 rupees. For site B, the fixed cost per year in rupees is 75 lakhs and the variable cost per unit is 560. And for site C, the fixed cost per year in rupees is 55 lakhs and the variable cost per unit is 4250 per unit. So we have to find the most economical location for our product, which has to be manufactured in 2750 number of units. So as we all know, fixed cost is nothing but the cost which will not change with the number of units of production, whereas variable cost is the cost which is calculated per unit. So if you are manufacturing X number of units of product, then you have to multiply X by the variable cost, which is 1200 for site A. So the total variable cost will be this cost, the variable cost per unit into total number of units that we are producing. So for each and every site, we will first try to find the total cost. Total cost of site A will be fixed cost of site A plus total variable cost for site A. So fixed cost for site A is 65 lakhs plus total variable cost is variable cost of site A into number of units of production, that is 2750, which is 65 lakhs plus variable cost of site A is 1200 into number of units of production is 2750. So if I calculate, the total cost for site A will come out to be 98 lakhs. Similarly, we will find out the total cost for site B, which is fixed cost for site B plus total variable cost for site B. Fixed cost for site B is 75 lakhs plus the variable cost for site B is 560 and the number of units is 2750. So it is 75 lakhs plus 560 into 2750. So if I calculate it, it will be 90 lakhs 40,000 rupees. Similarly, we will calculate the total cost for site C. In the same method, fixed cost for site C is 55 lakhs plus the variable cost for site C into total number of units that are manufactured. So it is 55 lakhs plus 4250 into 2750. So this will come out to be 17187500. So it is 1,71,87,500 rupees. Now we will try to draw a graph for which x-axis indicates the number of volume or number of units of production, and y-axis indicates the cost. Now if you suppose that y-axis is indicating cost or total cost or fixed cost or whatever, it is indicating cost. So if you observe this particular equation, this is in the form of y is equal to mx plus c. C is a constant which is fixed cost, m is the variable cost, and x is the number of units that are produced. So this may vary. We may not always fix to the production volume 2750. So this is the variable x, which is along the x-axis, number of units of production. Variable cost is also fixed for per unit. Per unit, this particular number is fixed. This is the slope of the line, and c is the y-intercept, which is the fixed cost. So this entire equation is actually showing the equation of a straight line. So we will draw 3 such lines for site A, B and C respectively. I am drawing the graph on a white paper, but you can use a graph sheet also. So the x-axis is indicating number of units, which is indicated by capital Q generally. Q indicates the number of units of production, and y-axis indicates the cost. So we are taking the scale suitably. So the number of units of production was maximum 2750. So I am dividing this line for unit or 1 centimeter equal to 500 units. And the cost, the maximum cost or the total cost, if you can see, out of 3 numbers, one is 98 lakhs, the other is 1,71 lakhs, and the other is 90 lakhs. So I am taking the graph which will cover this maximum value. So I am dividing the vertical line again according to suitable scale, say from 20 lakhs. So one division or 1 centimeter on the graph paper will indicate 20 lakhs. 20, 40. So I have divided the vertical line or the y-axis into 180 lakh units. So each centimeter is showing 20 lakhs. Now what is the y-intercept for the first equation, that is of the equation of site A, is y-intercept is 65 lakhs. So I will mark 65 first on the y-axis. So there is 60 here, so midpoint will be 70. So the midpoint of these 2 points will be 65. Somewhere here is our 65, and this is the y-intercept. Now what is the total cost? It is 98 lakhs for a given volume of 2750. So I am marking 2750 on the x-axis. So it is a midpoint of 2500 and 3000. Now I will draw a vertical line from this point, and I'll mark the total cost value also, which is 98 lakhs. So 98 is, there is 90 here, 98 somewhere here. So I'll draw vertical line from 2750 and a horizontal line from 98. So both of the two lines are meeting at this point. So from y-intercept, that is 65, and to this point I am drawing a straight line. Like this. So this is the total cost line of site A. Similarly, I will draw the total cost line for site B. So the y-intercept of site B is 75 lakhs. So we will choose 75. We will locate this point. 75 is here, and the total cost is 90 lakhs 40,000. So we will mark 90 lakhs 40,000 on y-axis again, somewhere here. So from this I will draw a horizontal line to meet the vertical line which is drawn from 2750. So from 75 lakh point, that is the y-intercept point, and to the new intersection point here, I'll draw another straight line. So this is the total cost line of site B. We'll again draw the total cost line for site C. So the y-intercept was 55 lakhs. I'll mark 55 here. 50 is the midpoint here. So 55 is the midpoint from 50 to 60. So this is 1 point, and the total cost was 1 crore 71 lakhs. 1 crore 71 lakhs. So it is 171 basically. So this is 170. So somewhere here lies our 1 crore 71 lakhs 87,500. So we draw a line, horizontal line from that point to meet the vertical line drawn from 2750. So I am joining the 2 points 55 and the new intersection point using a straight line. So this blue color line is the total cost line of site C. Now our main purpose of this entire exercise is to find the minimum cost site. Okay, so there are 3 sites, out of which until this region or until this quantity of production, site C is showing minimum, and there is another intersection point here which is showing another quantity of production. So until this region, between this line to this line, there is another site which is showing the minimum cost, which is the red color line out of 3. So this is close to the x-axis, so site A. So between this region, site C is the minimum cost, and between, in this region, site A is the minimum cost, and after this point site B is showing the minimum cost. So in order to know these quantities, let me say that this is Q1 and this is Q2. If you are doing this entire drawing this entire graph on a graph sheet, then you can directly note the reading here. But we are doing it on a white paper, so we'll have to calculate this particular quantity. So Q1 is indicating the intersection point of two lines, which is the straight line of site C and site A. Okay, so let us consider the total cost equation of site A, which is 65 lakhs plus 1200 into, here the quantity of production is Q1. So let me write it as Q1 because we are finding the intersection point. This is the total cost line of site A, which should be equal to the total cost line of site C, which is 55 lakhs plus 4250 into Q1, because the quantity of production is same. So if we simplify this, it is 10 lakhs is equal to 4250 minus 1200 into Q1. So from this we can find Q1 as 327.868. So if it is if the quantity of production is in liters or kilograms or tons or anything like that, then it can be a decimal value, but we are not sure whether it is a decimal, can be a decimal value or not. For example, if it is number of cars or number of mobile phones, so it can't be a decimal value. So I am writing it approximately to the next higher integer as 328 units. So point Q1 indicates 328. Similarly, we have to find the value of Q2. So Q2 is this intersection, is indicating this intersection point, which is the intersection of two lines, that is the total cost line of site B and site A. So site A equation, we have 65 lakhs plus 1200 into Q2, which should be equal to the side B line, which is 75 lakhs plus 560 into Q2. So from this we can find the Q2 value as 1562.5, or I can approximate it to 1563 units. So Q2 value is 1563. So we have found out the breakup of production volumes. So until your production volume is within 0 to 328, the preferred location would be site C. So between this region, in this region or in this region, site C is showing the lowest cost. This line is the lowest, this is higher, this is also higher. So the lowest line is indicating site C. So again, if the production volume is ranging from 328 to 1563, then the preferred location, out of these three lines we have to check. This is one line, this is another line, this is the third line. So out of these three, this is the lowest line, which is indicating site A. So if the production volume is ranging between 328 and 1563, site A is preferred. And if the production volume is greater than 1563, then site B is preferred. So if the production volume is greater than 1563, we have to check this region. So in this region there are three lines, site B, site A and again site C, out of which site B is closer to the x-axis. This is the production breakup. So if this production breakup is asked to find, then you have to do all this exercise, but otherwise you can simply take the total cost values of all the sites and choose whichever is minimum. So for example, total cost of site A was only 98 lakhs and total cost of line B, site B was 90 lakhs 40,000 and the total cost for site C was 1 crore 71 lakhs 87,500. So if the breakup is asked, we will have to do this break-even analysis. But if the breakup of this production quantity is not asked, then out of these three numbers, choose the lowest, which is site B, which is that of site B, which is showing only 90 lakhs. So straight away you can say that site B is the best location for a production volume of 2750.
Thanks for watching. If this video was of help to you, please like it and share it with your friends. And don't forget to subscribe to our channel.